Hi guys, so today we will be starting another topic, that is a new topic, that is solubility product. Okay, so this is a topic that is very important with respect to your boards and also NEET and JEE examination. So whether you talk about your board examination or you talk about your competitives, in both the cases this topic is super important. If you check any year paper of NEET and JEE, one after other year you will see that one problem has been asked from solubility product. In JEE you may see that as an indirect question, for NEET you will see direct question from solubility product. So it is a very important part and that is what we are going to study right now. Okay, so let us see whether we can understand it or not. I hope everybody will pay attention and you will be able to understand and score more in the upcoming examinations. Okay, first of all our topic is solubility product. ठीक है, so first of all we will be talking about solubility. So there are salts like NaCl, there is salts like Na2SO4, there are salts like AgCl, PbSO4, PbCl2, etc. So many salts you have heard about, and we have heard about there are certain salts which we called as insoluble salts, right, like AgCl, BaSO4, PbSO4, lead chloride. So many insoluble salts we have heard about. But what is the exact difference between soluble salts and insoluble salts? Is there a clear demarcation? Is there a clear demarcation between the two, or is it just that we say this is soluble, this is insoluble? Come on guys, you put NaCl in one glass of water, you will see it is soluble. You keep on putting it, after some time you will see it's insoluble. So you will call that soluble salt or insoluble salt. So there will be a demarcation for it. So there are three kinds of salt. One kind of salt we will call as soluble salts. Okay, if in case of soluble salt, what does soluble salt means? Soluble salt means that solubility of that salt inside water is more than 0.1 molar. That means when the salt goes inside water, the concentration can be maximum 0.1 molar. So if it crosses 0.1 molar, then we will call it solubility, very soluble salt. Okay, so that is a good solubility. So if solubility will mentioned as small s. Okay, so solubility, if the solubility is more than 0.1 molar, okay, if the solubility is more than 0.1 molar, then you will consider it as a soluble salt. There is another kind of salt which we call slightly soluble salt. Slightly soluble salt. So slightly soluble salt means the solubility is less than 0.1 molar. This we will call as slightly soluble salts. But there is yet another category of salts which we call sparingly soluble salt. That means even one, a single piece, a single small crystal if you put in the water, you will see it is insoluble. So there must be some reason to it. It's not getting soluble at all. Does that mean that not even one atom or one molecule of that salt is dissociating inside water? Is it like that, or there is something else? What does this really mean? So sparingly soluble salt. Sparingly soluble salts means the solubility in this kind of salts will be less than 0.01 molar. Okay? Solubility of this kind of salt will be less than 0.01 molar. That means almost insoluble. So what should be our point of study? Our point of study in this part of the chapter, that is ionic equilibrium, is basically this part. Why we are not going to study this part? देखो, जिस स्कूल में सब लोग पास हो जाता है, ठीक है ना, जिस स्कूल में सब लोग पास हो जाता है, उस स्कूल में क्या हम लोग खबर लेने जाते हैं कौन पास हुआ? हाँ, तो यहाँ पे मोरलेस लगभग सॉल्युबल होता है, सॉल्ट जाता है पानी के अंदर, that get ionized, right? But in case of this, that is this school, in case of this school, सब जनरली फेल होते हैं. तो इस स्कूल में हमको जाके देखना है इसमें कोई ऐसा बच्चा है क्या जो पास हो सकता है या पास होता है. सो कौन सा स्कूल में जाके हम पास परसेंटेज गिनेंगे? वो स्कूल जाके हम पास परसेंटेज गिनेंगे जो स्कूल में नॉर्मली लोग पास नहीं करते, ठीक है ना। हालांकि आजकल सब स्कूल में बहुत सब लोग पास करता है। सो दिस इज आवर पॉइंट ऑफ स्टडी। So we are going to study this kind of salt. Okay, clear guys? Okay, so can we name one or two examples for this? Yes, AgCl, PbSO4 already discussed. So those are generally sparingly soluble salts, AgCl, PbSO4. Clear? Okay, so now let us take a salt, an imaginary salt. Let's take AB. When it goes inside water, it should dissociate as A plus B minus. So this is the unionized form. This is the unionized form, and this is the ionized form, right? So if you see this unionized form, so we are talking about a condition when AB is in equilibrium with A plus B minus. What does this mean? That is, I have taken a salt AB. Here is my beaker of water. I have put some AB inside it. So some amount has dissociated like this, or we can say ionized. Others are like this. We are talking about a sparingly soluble salt. In case of sparingly soluble salt, most of them will remain as molecules, right? Very less amount of them will ionize and remain as ions. So these are the ions and these are molecules. So these are not going to generally form ions. Very few of them will produce ions. Now at what condition? At a certain stage after which it doesn't ionize, we call that equilibrium, right? So this is the equilibrium condition. So in case of solubility, what do we call this? In case of solubility, what do we call this? NaCl पानी में डाल दिया, डालते गया, एक टाइम के बाद NaCl नहीं घुलता है, नहीं टूटता है NaCl. So उसको हम क्या बोलते हैं? सॉल्यूशन क्या है? Saturated solution, है ना? That is saturated solution. So this is the condition of saturation. This is the condition of saturation. But in this chapter, this condition of saturation is also equivalent to the word that we have learned, that is equilibrium. Now this equilibrium is for what? This equilibrium denotes solubility. So we call this, what should we call this? We should call this solubility equilibrium. We should call this solubility equilibrium. Whenever this molecules, that is an unionized form of AB, is in equilibrium with ionized form, that is A plus B minus, in a solution, that will be called as solubility equilibrium. That is what condition? Saturation condition, saturated condition. Now this unionized form is what? This unionized form is undissolved solute. ठीक है? And this ionized form is dissolved solute. है ना? These two are in equilibrium. This unionized form, or you can call them undissolved solute, is in equilibrium with dissolved solute. ठीक है ना? So this we will call solubility equilibrium. After this we are going to take an example to find it out. First of all, you need to understand each and everything. थोड़ा revise कर लो. What happened? We are talking about sparingly soluble salt. That will be our point of study. अभी salt को पानी में घुला दिया तो क्या हुआ? That is going to dissociate into two types of ions, cations and anions. ठीक है ना? Cations and anions में dissociate हुआ. लेकिन ये क्या है? Sparingly soluble salt है. If it is sparingly soluble salt, then definitely not many of them is going to form cations and anions, right? So very few of them are forming cations and anions. But definitely this cations and anions, that is the ionized form, which we will call dissolved solute. This is dissolved, this is undissolved. This undissolved part and the dissolved part are in equilibrium with one another, and that is why no more dissolution is taking place. So even if one molecule of AB is going to form or dissociating into A plus and B minus, after some time this A plus and B minus is also forming AB, and the things are as same as it is. The things are 2 molecules of AB or 3 molecules of AB, but only 1 molecule or 2 molecule of A plus and B minus is there. Okay, clear? Next, let us take an example. So ultimately, see what is asked from it. What is asked from it is problems. So before we go into numerical problems, we must form some basis, some formulas from which we can do our numerical problems very easily. Some formulas से numerical problems बनता है. So we'll take one example as this salt. Okay, AX BY. ठीक है. Now you must be thinking, sir, what it will give? AX plus BY minus. कितना प्रॉब्लम है ना. देखो यही प्रॉब्लम अगर मैं तुमको ऐसे देता कि Na2SO4, so we could have फटाफट written what 2Na plus SO4 2 minus, because that is what we are accustomed with, right? Whenever things are given in ABCD format, we have a problem. This is the problem we are facing from those class 6, 7 I think, where we have just shifted from arithmetic, that is numbers, to algebra x, y, z. x, y, z आने से प्रॉब्लम हो जाता है, बट नॉर्मल तो अरिथमेटिक तो ठीक है. तो टाइम टू टाइम क्या हुआ, एल्जेब्रा आपका फेवरेट सब्जेक्ट बन गया और धीरे धीरे अरिथमेटिक तो आपका वीक हो गया. सो आई डोंट वांट एनीथिंग टू गेट वीक. So that is normal. You are accustomed with Na2SO4, you are not accustomed with this. So don't worry. It will give a cation, it will give an anion. Chalo. So let's take A as cation because it is written in the left hand side plus B. See, A and B must have formed AX and BY. So write A over here, B over here. ठीक है ना? Write A over here, B over here. So now suppose you don't know what is the valency of A. So let's take the valency of A as this one. ठीक है, valency of A, that is, so if you know the valency of A, then you can put over here. सोडियम का वैलेंसी मालूम था इसीलिए तो Na प्लस बिठाया था ना. सल्फेट का वैलेंसी मालूम था SO4 2 माइनस बिठा दिया. तो वैलेंसी मालूम कर, इसका वैलेंसी पकड़ लो A है, इसका वैलेंसी पकड़ लो B है. तो हम क्या करते हैं, क्रॉस मल्टीप्लिकेशन करते हैं. क्रॉस मल्टीप्लिकेशन करके हमको मिलता है ABBA. ठीक है ना. तो ये किसका वैलेंसी है, A का. ये किसका वैलेंसी है, B का. बट अल्टीमेटली जो फॉर्मूला है AXBY, सो फ्रॉम हियर आई कैन से A इज इक्वल टू Y एंड B इज इक्वल टू X. सो A का वैलेंसी क्या था, A, राइट, A. सो A क्या है, Y है, तो A के ऊपर क्या आएगा, Y प्लस. B का वैलेंसी क्या था, देखते B. सो B इज व्हाट, B इज X, राइट. So X minus. Now you will balance. So here is X number of A, so put here X, Y number of B, put here Y. Okay, clear? So this is how you do it, simple hai. Next is, if you want to find out the equilibrium constant for this solubility equilibrium, then let us see what we get. So first of all we get over here A Y plus whole to the power X, clear? You must be accustomed with all these things because this is done in equilibrium part 1, part 2. B X minus whole to the power Y divided by AX BY. Now just remember one thing, we are talking about this, though it is solid you can ignore it, but still see we are talking about something that is in equilibrium, है ना. We are talking about something that is in equilibrium, and equilibrium in case of solubility is saturation. So whenever a solid that has been dissolved in water and some part of it has dissolved, some part is there as solid. So does the concentration of that solid change? Does the concentration of that undissolved solid change? Never. It will never change because it has already reached saturation. So this part remains constant because we are talking about a saturated solution. When we are talking about a saturated solution, this part will remain constant. So we can write K AXBY is equal to AY plus whole to the power X BX minus whole to the power Y. This product is called, we will name it as KSP, which is called solubility product. ठीक है, which is called solubility product. So solubility product is actually what? It is a form of equilibrium constant for solubility equilibrium, nothing else. ठीक है ना? So don't take this as a different topic altogether. This is just a form of equilibrium constant for solubility equilibrium. So how should this value depend on many things? See, solubility basically will depend on, solubility product will depend on what? Solubility. So solubility will depend on what? Solubility depends on temperature. You have studied it in class 9th, right? Solubility depends on temperature. So if solubility depends on temperature, this will also depend on temperature. So remember one thing, बहुत important है ये, this is very important, remember this, remains constant. Solubility product will remain constant at what condition? If the temperature doesn't change, that is same temperature. Number 2, solute. For a particular solute at a given temperature, solubility constant doesn't change. The solubility product is not going to change at a particular temperature and for a given solute. Solubility product for AgCl is given in the table. Definitely at some certain temperature, table it is given at 25 degrees Celsius. So by now you know that 25 degrees Celsius is called the standard one, that is taken everyone, 298 Kelvin. So it is already listed in the table and it is not going to change because solubility of a solute at a given temperature is constant, right? NaCl solubility over here and NaCl solubility in London is same, it doesn't change if the temperature can be maintained, right? So you can say, you can argue, sir उधर पे 2 डिग्री आ सकता है, हाँ correct, that is correct, understood? So it will depend only on temperature and for a particular solute it is never going to change, it is never going to change. This concept will be important while you do problems, numerical problems in various competitive examinations. So you need to remember this one, okay? So that is all introduction of solubility product. Try to understand, and after that we are coming up with solubility product and another thing that we have already learned, that is ionic product. We will compare them and we are going to understand how does this affect the solubility of a solute inside water. ठीक है, देखो कर लो फिर आप